The question is, how many 7-digit positive integers are made up of 0 and 1 only and are divisible by 6? Since the numbers will be divisible by 6, it means that they will simultaneously be divisible by 2 and 3. Divisibility by 2 implies that the last digit has to be 0, because if it is 1, the number will be odd and therefore not divisible by 2. We also appreciate the fact that the first digit has to be 1, because if the first digit is 0, then the number will become a 6-digit number and not a 7-digit number, because leading zeros do not matter. Thus, there are 5 slots left in the middle which are to be populated by 0 or 1. A number is divisible by 3 only when the sum of its digits is divisible by 3. We can use maximum 5 numbers of ones for the remaining 5 slots to construct the required number. The possible numbers of 1 that can be used will therefore be 2 or 5, so that the total number of ones, including the one at the first slot, will then become 3 or 6. This will make the resultant 7-digit number divisible by 3. Therefore, the problem boils down to the total number of ways we can fill case A, digit 1 in all the 5 slots, or case B, with digit 1 in 2 of the 5 slots. Case A, the number of ways 5 slots can be filled with only ones is 1. Case B, the number of ways in which 2 slots out of 5 can be filled up by ones is combination of 5, 2, which is equal to factorial 5 whole divided by factorial 2 multiplied by factorial of 5 minus 2, and that is equal to 2 multiplied by 3 multiplied by 4 multiplied by 5 whole divided by 2 multiplied by 2 multiplied by 3, and that is equal to 10. Therefore, the total number of different ways for both cases will be 1 plus 10, that is 11. Thus, only 11 numbers of 7-digit positive integers can be made with only 0 and 1s, such that the numbers are divisible by 6. These numbers are written down below. Please check and convince yourself that there are no other numbers that satisfy these conditions. If you are familiar with binary number system, there is another way you can find the answer systematically. After realizing that the middle 5 slots can have only 2 or 5 numbers of ones, we can write all combinations from 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1 in order and select only those that have 2 or 5 numbers of ones. An orderly method to write all the combinations from 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1 is to write 0 to 31 in binary digits. like 00000 in binary is equal to decimal digit 0. 00001 is decimal 1. Like this, if you go on, you will find that 00011, that is decimal 3, has two numbers of 1, and this will be one of the candidates that will be fulfilling the conditions. Proceeding in this way, you go up to 31 decimal, which is 11111. In this representation of the different combinations, I have marked in green all the eligible candidates which fulfill the required criteria, and they total to a number of 11. Therefore, the answer is 11 numbers.